good afternoon to all the viewers. Sorry for the delay, so I was having trouble setting up the cameras and everything. So welcome, and this is Bhutan Space Week. So as I think most of you viewers know, so this is an initiative started by the Department of Information and Communication and Telecom. So I think this is the third forum for the forum. So today I will be speaking to you about geospatial data. Yes. So to introduce myself, my name is Kinley Wangyel, and I work with the Department of Human Settlement and Department of Human Settlement under Ministry of Works and Human Settlement. And as a background, my actual qualification is as an urban planner. So yes, but I really have an interest in geospatial data and technology. So I have been involved with certain projects related to geospatial information. So Ishe has actually asked me to do this presentation so that we have some kind of awareness among our Bhutanese society about the application of spatial data, satellite data, and in general science and technology. So to begin, okay, I'll just set it up. Okay, so technology and application of geospatial data. So I think some of you might know actually what geospatial data means and the applications of satellite data, and some of you might be really adept at applying it. But this presentation will not be too technical. I'll be basically introducing what are some of the technology and data that we use in terms of let's say, for example, planning human settlements in our country, and also the application of geospatial data and integration with artificial intelligence in other countries. So just to begin with, I'll just introduce you to this. So this was something I came across while doing research. So this 5-character word, well, if you look at it, it doesn't mean anything. It's not a word, but this uniquely identifies this blue box. So there's an algorithm called GeoHash. So if you run this five-letter word through this algorithm, this will uniquely identify this blue box anywhere in the world. And you can do that for anything, any place in the world. So to describe it, you don't actually need to say Tempu. Tempu is actually a longer word than the word previously shown, but that can actually identify this space uniquely. So those that was one interesting concept that I came across. So okay, so anyways, I see some comments in the comment section. So if you guys have any questions to ask or anything, you can just leave it in the comment section and I'll try to answer it at the end of this presentation. Okay, so just to proceed, and it's just as an outline of the presentation, I'll be giving you a brief background and introduction to what it all means. So basically this will be what just a simple introduction for those of you who are not really aware of all of the terms I'm talking about. And next will be the current applications both within and outside the country, and how it has helped during the current situation we are in, which is the COVID-19 pandemic. And then I'll just talk about a little bit about the technology that has been used. So it's basically basically for those of you out there who want to try it for yourself, I'll just give you a brief introduction, and then we'll talk about the data sources, which is the source of satellite data and how we collect data, how we go about integrating it into our daily lives and daily systems. Then lastly, I will talk about the integration of satellite data, basically geospatial data, with artificial intelligence, which is quite an quite a developing and interesting field of study nowadays. And okay, so just a background and introduction. So basically, when you talk about geospatial data and the related technologies, you'll see the term remote sensing. You'll come across this term a lot, remote sensing. So what does remote sensing mean? Remote sensing is the acquisition of information about an object or phenomenon without actually making physical contact with the object, which is basically a satellite, or maybe if you, let's say if you take a photograph from a helicopter or an airplane, which that is collecting information about the surface of the earth. So remote sensing is sometimes synonymously used with collection of satellite data. And if you see on the right, you can see this is one of the most popular applications of satellite data. So this is basically detecting changes in land use, or let's say changes in the in the example, if you can see, it detects the change in the water bodies starting from 1988 to 2008. So in that way, we I think we can say that we can apply this in detecting the change of glacial lakes, and it has even been used in the detection of change of detection in the Antarctic and Arctic glaciers in the surfaces. So those are only few applications of how few applications of satellite data in our daily lives. So which is actually a scientific application, because the scientists use it to identify the rate of change that climate change is having on the earth. And so what are the applications that we actually do in our country, as like specifically for my division and my line of work? We use satellite data to collect information about planning human settlements. So as you can see on the right, this is the digitized version of this Pavisa, near Pavisa. So all of those blue lines are actually has been actually digitized by our team of planners and volunteers during the COVID-19 task force in Nalu. So they have digitized all of the building footprints as a part of collecting the information for this COVID-19 task. So in our system, so in our planning, human settlement planning, we actually use all of these data to collect individual informations about buildings, and all of this can affect how we make our plans, or how we plan our settlements. So during this, we come across other terms, some terms such as photogrammetry. Photogrammetry is actually determining the dimensions of terrains and other information through satellite data. So satellite data, they don't just collect photographs of the place on Earth, but they also record all of the electromagnetic spectrum, through all of the range of electromagnetic spectrum that is emitted off the Earth. So with that, you can get a lot of information regarding the terrain, the height of buildings sometimes, and as you can see in the pictures, you can see that there are shadows of the building. So using some specialized software and all, you can actually determine the height of the building. So even by observation, you can see that this building will be taller than this by judging the length of the shadow. So those are some of the techniques which are used to actually decipher all of the information given to us by the satellite data. So photogrammetry is basically that technology and that specialization. And the other terms you come across are geospatial data, which basically means any data which has like a link to geographic position. So let's say if you say building A has 5 people, then that's not geospatial data unless building A is specified on the ground. If you say that on this latitude and longitude you have this number of people living, then that can be called as a geospatial data, because that identifies the specific position on the Earth's surface. So basically that's geospatial data. And then another popular term that you come across is geographic information system, which is a collection of software for manipulating and analyzing all of those geospatial data. And the next is topographic analysis and cartography, and the tools used are as mentioned. So I'll just go through some of the pictures. I'll not bore you with the details. So this is one of the plans that we have made for not exactly plan, but one of the topographic data. So as you can see, it is linked spatially to, it is a geospatial data because it has been linked on the ground with some reference system. So we see all of those lines which are showing, all of those yellow lines which show the slope and topography of the area. So this is actually on the Bhutan. And using this, we can actually plan for human settlement, how we can sometimes we can't build on steep slopes, so all of those things can be determined by analyzing all of these details. And we can also do flood analysis by basically letting the settlements out of danger for flooding, and all of those analysis can be also done using all of those data. And as I've mentioned before, topographic analysis. So this is Panbang Panbang in Shamgang, Panbang Tungkak, I think. Yeah, Nanam Tungkak, sorry. So in here we have done a slope analysis for the Tomde. So all of the red areas show the places where it is really hard to build settlements, because as such we can't build above anything on a slope greater than 30 degrees. So we can show all of this, and this purple lines also show the river buffers for the area. And we also integrate that with the cadastral data, meaning the plots, individual plots, and also with geotechnical studies that have been done. So finally we produce something called a land suitability analysis, or land suitability map. So what this does is actually show you where the settlements are possible, where all the areas are which is possible to make settlements. So all of these red and pink areas show it is not suitable for any kind of settlement, whereas all of those areas which are not colored are very suitable for settlements. So as a result, we see so all of those white places are all the places where there are settlements. And another application that has been extensively used in our country is land use and land cover classification. So I think if some of you are from the agriculture and livestock ministry, Ministry of Agriculture, so you might know this, which is the land use and land cover classification. So basically what this does is classify the land use according to the type of cover or land use they are. So basically the classes of land use that is used in Bhutan is basically forests, different types of forests, then human settlements, and basically 5 or 6 classes. I don't remember all of them, but so those are the classes which are produced. So when we say like Bhutan has 60% forest cover or 70% forest cover, this is a source of data that we use. So all of those satellite data determine where the forests are, or where all of the settlements are, and then we determine what percentage of our country is actually under forest cover. So some of the technologies which are used are ArcGIS, QGIS, which are basically softwares, and I think some of them might even use another software, but the underlying technology is they use something called a supervised classification algorithm and support vector machines, which is a subset of supervised classification algorithm. So what this does is takes samples of all of the forest covers and all of the human settlements, and try to classify all of the country based on those parameters. So as a result, you can see this is the land use land cover map of Bhutan for 2016. So all these different shades of green show forest cover, and if you come towards this side, on the red side, you can see it's Timpula. So which means the red areas show all of the human settlements which are being which are there on the map. So using all of those softwares that I mentioned before, and all of those specialized algorithms before, satellite data can be classified according to the use. So that is one important application of satellite data in our country. And coming to the next application, so this has been done recently. So this is an application for the mapping. This is a mapping application for issuing COVID-19 passes. So I think most of you might be aware, during the recent lockdown or the current lockdown, we have been issued a lot of movement passes, and we have been divided according to the zones. So during that time, I was with the movement pass team, and we have mapped out all of the buildings on the ground and issued movement card according to the zones. So we also collected a lot household information of all of the people residing in the zone. So that way we can see that, and I think in the future we can use that data for delivering or managing resources. So how do we allocate resources according to the number of people in the zones? How do we deliver or prioritize zones according to the risk factor? And all of those numerous number of applications can be developed using this data. And as of now, I think the data is almost complete, but we are currently in progress for applying all of those data. And the next application I would like to see is this might be really familiar to all of you, which is navigation and routing. So with the use of the GPS on our phones, like global positioning system is embedded in our phone, we can actually see where our positions are. We can use all of those different mapping applications like Google Maps or Apple Maps, or some other applications to determine the direction we are going in. So we can specify a source and origin and destination, and then the mapping application will show us the shortest route to that destination. So that is on the surface, on the user interface level, but actually inside what it is using is basically certain algorithms and certain specialized softwares. So for Google, they have something called a directions API, which actually makes it possible for you to determine the direction and or maybe the shortest route between 2 points. So it is closed source. They don't actually reveal how it works, but my guess is they use something of this level. So if you are specializing in finding directions, or if you want to research it, you can go ahead and look at these two algorithms. So one is called Dijkstra's algorithm, and another one is called A-star algorithm. So these two are the premier algorithm for finding directions in any kind of network graphs. So the implementation is actually shown in PG routing and graph hopper. These are two extensions which can be used with certain databases and certain softwares like QGIS. You can use that those extensions to actually find directions. So what we are trying to do is right now implement those all of those features into a project. So this is some side project we are working on right now. So it's called myhome.bt. You can access it if you want. So in this we have assigned street addresses, which is courtesy of National Land Commission, that they have done this street addressing for the COVID-19 recently. So if you see, this is just Shuzong area. So we have all of those road names assigned in this place. Like for example, this road is called Desi Lam. Then we have building numbers and all, which they have done. So you can uniquely identify this building according to the road name and the building name. So this can be really helpful in something like delivery systems, or maybe if you want somebody to deliver something to you, or somebody is trying to find a direction to your house, then maybe you don't have to say you live in beside the road or beside the tree or something like that. Maybe you can just use the address given to you. And also it's currently under work, but we are trying to implement what Google Map is doing. We are trying to implement this directions in the space, so maybe in the future you can use that. And so another application that is quite interesting and it's been around for quite some time is traffic data. So I think this feature is exclusively available on Google Maps, but I'm not sure, but I think Google Maps is the most popular. So as you can see in this example, we see that Google actually shows where traffic is. Like let's say this is a hospital area, so you can see there's a traffic speed is less around this, so which is quite true actually. So if you go about collecting data from here, you can, or maybe if you go about observing from here, you can see that it's actually true that when you drive around, you always slow down around this point because of the heavy traffic. So how does Google collect all of this information? Actually, Google really doesn't reveal all of those applications, how they use or how they collect all of those information, but I think one man has found out how they do it. So it was recently in the news. So a man fooled Google Maps by using 99 smartphones. So he loaded all of those in the trolley, and he walked around a street which is basically no traffic, but in Google Maps it was showing that there is heavy traffic around this area. So what Google Maps was usually doing was they were collecting information, like on our phones, on our smartphones we have this GPS, so it can also track speed and the rate at which we are moving. So all of those data are fed into the Google server. So actually in the map it was showing that it is quite a heavy traffic, but in reality it was just one man strolling around. And coming to coming to the technology that is used for for information or maybe analyzing or all of those which I have shown before. So these are some of the these are some of the softwares which are used in making all of those technology possible. So I'll not go into detail because this is I think this is not really a technical forum, technical talk. So maybe if you are interested, you can just ping me up, so we can discuss all of those technologies. So but yeah, basically for me, I think mostly use this leaflet to render maps, and for some of my colleagues, I think in the ministry, we almost always use ArcGIS and QGIS for analyzing and all of the data analysis that we do. And to actually get a grasp of all of these technologies, it is important that we have some idea about geography. So something like coordinate systems and latitude, longitude, just basic stuff. So if we have a little basics about all of those terms and all of those, so yeah, if we have some idea about those, then I think it becomes easier when we do all of those programming and all of those, making those technologies possible. And data sources. So data source, just to give a certain terminology. So when you open Google Maps, the first image you see is a satellite image. So all of those satellite images show up on your phone. They are called tiled data source, or this term, tiled data source. So all of those satellite images are divided into tiles. So this tile can be specifically rendered to you according to the XY coordinates that you are actually looking into. So these are called tiled or raster data sources. They are also called raster data sources. So some of the most popular data sources are Google Maps, then Bing satellite images, and Yandex, or OSM, which is again another popular choice, which is available. I think it's open source, and they have a lot of information which is crowdsourced. So I think it's a good source of data. And for Google or Bing satellite images, they just give it give you the viewable images, but I think to actually have a usable image, it's not really open source. And USGS is another open source repository which is good. And coming to other data source, okay, so this is another example, but this okay, so I have talked about tile data source in the previous section. So this is about vector data source. So this is another type of data, but for this I think some of you might be aware, so we call them shape files or GeoJSON files. So all of these are called vector data sources. So the difference is that tile data source is something like PNG images or JPEG images, which basically just show a background image. But vector data source, they actually give you certain points. For example, let's say if you have a polygon or boundary of a Dzongkhap, so then all of those vertices will be given in the latitude and longitude, and you can map them out with some specialized software. So all of those are called vector data sources. But as I said, it's not really important to remember all of those, but if you want to research and go further, then you will come across all of those terms, and please don't be intimidated by those terms, because they sound really complicated, but when you actually delve into it, it's really simple. It's a really simple concept, and for some I think it might be really interesting also. And coming to another section of data sources, so we have some tools to collect primary data sources. For example, to actually go in the field, we use the we have those GPS, RTK GPS or GNSS, which we use to collect building footprints, which is very accurate, but I think it requires some technical competency to actually use. But for simple data collection like the one we are doing right now for the COVID movement pass, we use web apps or any kind of app to collect information. So these are, so to, if you really want to look into it, I think these two are the popular mobile apps that are available to collect data. So Survey123 is by Esri, so it's not open source, but EpiCollect is open source, and I think some of you might have also used it to collect information. So things like these, this is for EpiCollect. So if you point out in a map a position which is captured by your phone, then you can click a photo or put some names onto it, and you can save that data for later. So these are some of the technologies available. And coming to this section, so I find this section at the forefront of what we are doing right now. So it's quite interesting to say that artificial intelligence and all of those related technologies are finding a lot of use in interpreting satellite data. So just as an introduction, artificial intelligence has been gaining a lot of popularity nowadays. So one of the most popular application, I think most popular form of artificial intelligence is neural networks. So for images, we have something called this convolutional neural network. So you might have seen this example, like the digits are hand drawn, so we feed this into a AI model, which actually interprets the number according to the handwritten symbols. So you can see this is 2, so the model identifies this as 2. So actually a lot of people confuse, like AI does some really simple work, so why is it called so advanced? Well, it's mainly for the reason that AI computers find it really hard to do things that we find really simple. So let's say, for example, for us it's really simple to identify between a dog and a cat, or maybe it's really simple for us to, maybe, let's see, if somebody tells us how are you, then we say we are fine, but for a machine to actually do that, it's really complicated. And machines can do a lot of mathematical calculations really fast, but for them to do something like human, or basically it's rather hard for machines to have common sense. But I think uh, artificial intelligence is a way to actually make all of those things possible nowadays. And so some of the technologies which are used for programming or making neural networks possible are TensorFlow, PyTorch, and some of those are many more other tools now. So how is it actually used in satellite data? So I took an excerpt from those applications which was presented to Esri, and these are actually not applied because the field has not advanced yet to that level, which people find really applicable. But I think we are putting a step in the right direction. So this was an application by Esri. I think this is in California. So what they are trying to do is find all of those houses which have a pool. So as you can see, all of those green labels, they were trying to identify houses with pools, and as you can see, sometimes all of those red were mistakenly identified for not having a pool. So there's always a chance of error, but I think you can see almost 90% of the houses were correctly identified. So what they were trying to do is plan out all of their they have this spray for preventing mosquitoes. So they were trying to plan out as to whether all of those houses need to have those sprays being done. So they took satellite data, then they fed it to the AI model, then the AI model gave a result which gave all of the houses which had a pool. So then it became easier for them to actually go out and plan their route for spraying all of those chemicals into their pool. So the work was made much faster. And the next application I think is interpreting aerial data or satellite data. So in the same way that example I've shown before, so what they were trying to do was basically make a land use land cover on steroids kind of application. So as you can see in the picture, all of those green areas were correctly identified as being forest covers, and all of other were shown to be barren. So in that way they were able to, let's say, identify all of those features on the ground without having a lot of human input. So all of those were automated, so to speak. So AI in GIS has reduced a lot of human input needed for making the things which actually before required a lot of effort. So it's even true in photogrammetry, because as you can see in this picture, the AI model has correctly identified all of the roads, all of the road network on the image. So traditionally what we had to do was actually manually digitize all of those lines. So we had to show which lines were, we had to manually uncover which lines were road, then identify them, then map it on the ground and everything. But with this AI model, it can do it in one swoop, and the best thing is that you can automate it for thousands and thousands of acres. So, and this is another application. So as I was saying before, so AI model has helped identify all of those building digitization for I think this is in Los Angeles, I'm not sure, but they have correctly identified all of those building footprints. So as I showed a picture in the previous in the beginning of the slide, so all that digitization can be done by this AI model. So it reduces a lot of maybe human errors and human effort. So I think AI in GIS is advancing quite a lot. And we also have other applications like machine learning algorithms have been able to correctly identify which crops were growing on which land. So they trained certain models, and so the first is the input satellite data, then it was fed into the machine learning model. Then after that, they can it generated an image showing all of the different kind of crops that were grown there. So coming to one of the applications of AI that we did in our study, this was done by me and some colleagues in our ministry. So we basically tried to determine the urban growth of Finseling. So we are basically trying to predict the urban growth of Finseling as to for the future years. So to actually predict the growth of Finseling, we needed some past data. So these were 7 parameters that we came up with. And, I won't go into the details, but let's just say these were parameters which were used for determining the growth. So actually back in 2017, so we compared the data between 2017 and 2004. So between those periods, we detected all of the changes. We detected all of the certain parameters about how the Tomde has grown with influence from those parameters. So these are the 7 parameters that we have used, and we fed it into an artificial neural network. So it is a simple network that has been used to predict based on those 7 parameters. So we trained them in a Google Colab machine, and the result was that we correctly predicted for 2017 with up to 80% accuracy. So if you see on the map now, this was the actual growth of Finseling from 2004 to till 2017. So this yellow part shows the urban boundary or maybe urban settlements in 2004, and the pink part shows the built up in 2017. This was the actual growth, and now our model predicted this almost the same areas of growth. So if you can see, those orange parts are all of the areas which our model has predicted for 2017. So on comparing those two results, we can see, we observed that it had almost a 80% accuracy in predicting all of the urban growth. So then we applied that concept, and then we predicted for 2027. Sorry, 2029. So combining those maps, so in Finseling Tomde, this is the main Tomde, and this is the other part. So using that same model that we have predicted for 2017, we predicted for 2029. So now we can see that those yellow parts are projected to be growing, and we see a lot of growth in this area as well. So I guess we'll see in 2029 if this data is actually correct. So yes, so that was one of the applications that we did. And okay, so another application or another aspect of satellite images and geospatial that I've not mentioned is geolocations. So I think GPS locations and geolocations are common to most of you because you have your smartphone. So when you open the map application, you'll find that you can easily find your locations and everything. So it's actually with the help of 31 satellites, or I don't know, 31 satellites are in the sky, which are actually helping you determine your position on Earth. So it's said that when you open your map application on your phone, it actually connects to the satellite at least three satellites in the 3 satellites in space to actually determine your position on Earth. But as always, there is a degree of inaccuracy related to GPS, so which I think you'll know, because when you open your map, sometimes it shows you in an entirely different Zongkak than you're in. But that can happen because satellite technology is quite old and it hasn't really advanced. But I think now with the advancement of artificial intelligence, geolocation is also getting a lot of advancements. So one technology that I found interesting was this a company called Scape. So it was recently acquired by Facebook, but what they did was they actually determined the position of your location depending on the photographs that photograph you are taking. So just to show an example, I'll just show this example. So so as you can see, they have this app. This Scape has an app which they use to take a photograph or maybe a video. They just point it somewhere, and automatically your position is determined without using the GPS. So those were, I think, one of the most advanced and sometimes scary development in the field of global positioning and geospatial data. So basically what I'm trying to say is, like, if you take a photograph somewhere, then somebody can determine, like if you take a selfie somewhere, then somebody can determine where you are right now using just your photographs. So that was one of the advancements, the interesting advancements in AI. And so even Google has done a similar application, but it's not as advanced as the one I've shown you, but they can determine which continent you fall on, so using the same concepts. So if you take a photo of some place, then it directly shows you where you're located, which continent you're located. And I think it's quite an advancement in the system, because Google has a massive database of street and photos. So they are using all of those data to actually determine the location of people, determine the location of phones and everything. Okay. So I think that's it from me. If you have any questions, okay, I see some questions in the comments section. So okay. Okay, so I think I have a question from Ishe. So how can the public participate in data collection? Is it advisable? I think it really depends on the kind of data you're collecting. So for this, let's say for an example, for this COVID-19 movement pass, we have been collecting data from the people for the households they are in, number of people, the household. Of course, it's sensitive, but sometimes we need those kind of data to actually plan our resources and everything in a particular way. So it really depends on the type of data you're collecting, and if it's really sensitive data, then I think the public should not participate, or maybe we can put in some measures of security or privacy to for the people to actually ensure that their data is protected. So yes. Okay, so another question from Ishi. So is there a specific app or tool which laymen can use to collect data in local context? So, for example, what would be the best tool to use if residents of various zones were to locate shops in the zones? Okay, so this, I think you might be aware, and most of you might be aware, you have those interactive maps in your Facebook, and those were used to determine the shops or the place of vegetable vendors and everything. So I think it is a very good application of maps in our current situation. And with some of my friends, I'm trying to also come up with this application in our myhome.bt application. So I guess in the future we can also track, we can also allow people to upload their locations, position of the location the same way you do it on Google Maps, and I think that can be used in the future. Okay. Okay, so Kazong has already answered that. Okay, so I have a question from Tashi Jamal saying, can you smartphone could update information location on an open source street map, please? I think that will answer issues for you. Okay, I think I really can't share the screen on this Facebook Live, so it's not really possible. I can just maybe I can just show it to Isha, or maybe anybody who's interested, you can just message me. So, okay, if you have any more questions, you can just post it on the comments below, and I'll try to answer you. I don't know when the lockdown is going to open. That was my friend, by the way. He asked me a question when the lockdown is going to open. Okay. So I have a question from Yangchen, which geopositioning, does it app work in Bhutan, and what are the major difference it has from Google Maps, and other than locating our position? Okay, so I think what she is trying to talk about is she's trying to talk about this. Correct me if I'm wrong. Okay, so this app is only available for London, so only they have used this app because they have collected data for only London. But I think in the future maybe we might see it in our country also, or maybe we can develop this for our country also. Besides positioning or locating positions, this has also been used to make augmented reality models. Like, let's say for example, if you make a model of a building, you can locate it on a certain position, and this app will actually make it make an augmented reality version of it, so that you can see it on that exact position where it is shown now. So that has been one of the applications, but it's very nascent right now. It's not really been widely used, so it's kind of a budding technology. So yes, maybe we can see it in the future in Bhutan. Okay, so I have another question from, what kind of satellite imagery is used for spatial analysis? Okay, so any kind of spatial satellite data, like for example for land use, land cover data, we have those Landsat images which have certain bands, like band 1 to band 8, or I'm not really sure, but they have a certain bandwidth, so they can use those bands to identify where if there are settlements or if there are forest covers. So all of those can be fed into the softwares I talked about. So using those softwares, then we identify the land use, land covers. So those are one kind of spatial analysis, and basically yes. So satellite image is the sometimes the source of data for us. So that is one way to describe it. Okay, so I think I have some work to do, so I think yes, so I'll end the live video here, and if you have any more questions, you can just directly message me, and I'll try to get back to you as soon as I can. So, and if you're interested to learn some of the technologies that I've shown to you in this video, then you can also ping me up, and I'll try my best to actually give you all of the resources and everything to learn all of those data. So I think that's from me. So thanks for having me, and thanks Bhutan Space Week and Yeshe for making this possible. And I'd like to thank the director of Department of Information and Technology for bringing all of these things and bringing all of us together. Yes, thank you.